Hello everybody, welcome to Memoneet. How are you all doing? I hope everyone is doing good. So, I'm Aprajita, your chemistry SME. I welcome you all to our next set of lectures. Okay, so I hope all of you gave your part test 1. Yes. So I think that went well and we have uploaded the video solutions for you as well. So kindly go through the video solutions of that part test. So to see what are the answers for the questions where you have got wrong and what are the improvements that you can make. Okay, so all the clarity you will get by watching those video solutions, right? So yes, like I can see most of you have started the preparation, right? And you have watched the first lectures also, like on the some basic concepts of chemistry, and you people are here in the second lecture as well. So you know what that means? That means that you people are consistent. You people are serious with your preparation. You are consistent, means you are consistently watching the lectures, and that's why it's so good to see you people are again here watching this lecture today, right? So now you know that these lectures are related to your Brahmastra test series. So we are going to have the next test very soon. All right. So the BPT 2, that is your second part test, that is going to be there on your 2nd of June. So we are going to study this chapter that is going to be asked in your Brahmastra part test 2. All right. Now you will see that the chapter name is given here, that is solutions. Okay. Now first of all, if anybody is watching this video for the first time, let me tell you what is this BPT and our Brahmastra test series. So we have planned a test series for you people to guide with your preparation throughout the year. So there will be 36 part tests and like 26 part tests, total 36 are there, 26 part tests and 10 full test. Okay, and that are actually designed according to the Neet, right? Neet pattern, exactly just like the questions are asked in Neet, and following the NTA pattern. That is very important, right? So other test series are there. We like just we don't have very high level questions or very low level questions like other test series. We have explained or we have arranged the questions in such a way such that it is according to your the NTA pattern. Okay, so that is why it's important for you to write the exams, and our first part test has already been over. We have designed these tests in such a way such that you people can simultaneously cover your 11th and 12th class syllabus, right? So today the chapter that is going to come in your part test 2 is solutions, and you know that this chapter is from class 12th and the last chapter was from class 11th. So you see, we are telling you that we are going to complete the 11th and 12th syllabus simultaneously. So the first chapter we are going to take for class 12th is solutions, and yes, it is an important chapter in your physical chemistry portion, right? So what is the benefit of attempting this test series? That you will get an idea about the NTA mindset, right? So you will see what kind of questions are being asked in the paper, and you will get a hold of it, and what kind of questions come from a particular topic. Like you might have attempted the test from this BPT 1, so you might have got the idea what kind of questions are going to come from some basic concepts of chemistry, right? And we have given you whole 50 questions from that chapter, so there is no way that any kind of questions would have missed, right? Because in paper you will get 1 2 3 questions, right, from that chapter, but now here you have got 50 whole questions. So see, that will be covering all the type of questions that we are having from that chapter. Similarly, this will continue for all the chapters. So for chemistry, the syllabus for part test 2 is the chapter solutions. All right. And today we are going to have the first lecture for solutions. So I have written the topics here. The topics we are going to cover here is types of solutions, concentration of solutions, solubility, vapor pressure of liquid solutions. See, it's not like easy to complete the whole chapter in just one lecture. Okay, that will be very tiring for you people as well to complete it in one sitting. So I'll be dividing this whole chapter into 3 parts. 3 video lectures will be coming. So for today's lecture, these are the topics that we are going to study. Okay, so just like I always say, take your notebook and pen along with you. Take down the important points. Notes will be provided to you, but again, it's very important when you are studying, you should have a notebook and pen with you so that you can note down the important points that we are discussing. Okay. And students, if anybody has not yet joined our Telegram channel, please join the Telegram channel. There you will get everything about this Brahmastra test series, all the planners, everything. There we give you daily targets, and interesting quizzes also happen in that Telegram channel. Okay, so don't delay it. Please join the Telegram channel. The link will be provided in the description. So please make sure all of you, those who are watching these videos, are going to join the Telegram channel. Okay, so let us start with our today's topics. So students, you might have studied about what are solutions in your lower classes, right? So let's have a very quick introduction about that. Okay, see, if I talk about solution, so it's a homogeneous mixture, right? And by homogeneous mixture, what does I mean? It means that whatever the components present in this mixture and whatever the properties are, they are uniform. Okay, means throughout the mixture there will be constant composition and constant properties, they will be uniform. So that's a homogeneous mixture of 2 or more components. It can be more than 2 components as well. So there are 2 components of this solution basically, that is solute and solvent. Now what is a solvent class? Now solvent is something that is present in the largest quantity. Okay, that component that is present in the largest quantity is the solvent, and it is usually the one that determines the physical state of the solution. This is very important. The ultimate physical state of the solution will be decided by the solvent, the one that is in largest quantity. Okay, and another substances or components, whatever are there in the solution, they will be known as the solute. Okay, means other than solvent, whatever you are having, that will be your solute. So in this particular chapter, we will be mainly focusing on binary solutions. Now, what are binary solutions? These are the ones in which there are only 2 components. Okay, one solute, one solvent, 2 components will be there, and those solutions we are going to learn about. Now, if I talk about the types of solutions, this is just a very basic overview because we are starting with the basic. Okay. So according to the phase of solvent, we have these type of binary solutions. See, gaseous solution means ultimately where the physical state is the gas. Okay, so it's gas and gas type, like mixture of oxygen and nitrogen, or you can say air. Liquid in gas means when chloroform is mixed with nitrogen. These are the examples that we have taken. Okay, solid in gases, they are like camphor and nitrogen gas. Then liquid solution means where the physical state is liquid. The physical state of the solution is liquid, right? So that is gas and liquid, like some gases are dissolved in water, oxygen dissolved in water, CO2 dissolved in water. Liquid in liquid, most common type of solutions like ethanol dissolved in water. Solid in liquid means glucose dissolved in water, salt, sugar dissolved in water, right? Now you know students that there are solid solutions as well. Like the physical state is solid, like gas in solid, solution of hydrogen and palladium. Liquid in solid, amalgam of mercury with sodium. Solid in solid means your alloys. So the alloys are the ones which are your homogeneous mixtures, means they are the solid solutions. Okay. So basically in this chapter, we are focusing on liquid solutions. So the very basic thing we will be learning about is the concentration of solution. Ki how we are going to express the concentration. Acha, do you remember in the last session when we talked about the basic concepts of chemistry, there we learned this. What is concentration? Concentration means amount of solute present in a solution. Okay, how we are going to express this amount of solute that is present in the solution is called the concentration. It can be done in two ways, students. A qualitative way is there and then quantitative way is there. So qualitative mein we will just say ki whether the solution is dilute or concentrated. Now what does that mean? Dilute solution means the one having very less amount of solute in it. Okay. Whereas concentrated solution means the one having more amount of solute, like large amount of solute is present, that will be concentrated solution. Okay. But can you tell me ki how much solute is present by this way? No, right? I can't tell you ki how much is there. I can just compare ki whether it's less or more. So for that we have some quantitative methods. So these methods that I have taken here are all the quantitative methods. This we have learned in the last session also. Okay. So mass percentage means whatever is the mass of that component in the solution and divided by the total mass of solution into 100. So that will be your mass percentage. Okay. Then volume percentage means volume of the component in the solution divided by total volume multiplied by 100. So that will give you volume percentage. Okay, like say I have 10% acetic acid solution. Now what is 10% acetic acid solution means? That I am having 10 ml of acetic acid which is dissolved in the solvent in such a way that the volume of the solution is 100 ml. Means in 100 ml solution I am having 10 ml of acetic acid. That is the 10 ml acetic acid solution. Okay, that is volume by volume percentage. Now students, mass by volume percentage means mass of the component that is present in 100 milliliter of the solution. So that will be mass by volume percentage. Now what is this ppm, parts per million? Students, this one is used whenever your solute is in trace quantities. Trace quantities means very less amount. So in that case we use this ppm. So ppm means what are the parts of the component, number of parts of component divided by total number of parts of all the components in the solution into 10 to the power 6. Okay, so we'll multiply this with 10 to the power 6. That will give you the concentration in ppm, that is parts per million. Okay, for example, I tell you, see if I am having let's say 6 into 10 to the power minus 3 grams of the solute which is dissolved oxygen in 1 liter of seawater. So 1 liter of seawater means it's 1030 grams. So it means I can say that I am having 5.8 grams of this dissolved oxygen, right? 5.8 grams, like if it, so means if we calculate, it will come out to be 5.8 grams. So 5.8 gram dissolved oxygen is present in 10 to the power 6 grams per 10 to the power 6 grams of your water. So it means I can represent this as 5.8 ppm. 5.8 ppm is the concentration of oxygen in the seawater. Okay, that's the thing. Now next up are the other important ways to which we represent the concentration. Mole fraction, you know, mole fraction of any component means the moles of the component divided by total number of moles of all the components. Let's say if I am having a component A, so that's mole fraction would be Na means number of moles of A divided by number of moles of A, and B means total number of moles. Okay, so in the same way I can say Xi, if I is any component here, then it will be Ni divided by N1 plus N2, so on up to Ni. So I can say it's Ni upon sigma Ni. Okay, and you must know that the total of all the mole fractions of all the components is going to be 1. If there are two components, so Xa plus Xb is going to be 1. Okay. Now the other important terms are molarity and molality. So you know about molarity, we discussed it in last session also, that it's the number of moles of solute divided by volume of solution in liters. And then molality means number of moles of solute divided by the mass of solution in kg, means how many moles of solute are present in per kg of the solvent. So that gives us molarity. Usually we use molality. It's like the most common one that is used to represent the concentration of the solution. So these are the different ways, students, in which we represent concentration of the solutions. Okay. Now students, we will be talking about the solubility. Okay. Now solubility of solutions. What does that mean? Solubility means the maximum amount of solute. Okay. Maximum amount of solute that can be dissolved in a specified amount of solvent at a specific temperature. Okay, let's say if I say that the solubility of sodium chloride is 40 grams at 25 degrees Celsius. I'm just taking a random value. Okay, that means the solubility, the maximum amount of sodium chloride that I can dissolve in, let's say, 100 grams of water or 100 ml of water is 40 grams, okay, at this temperature. So that is the solubility. Now, you know, this solubility, it is actually affected by many factors like nature of solute, nature of solvent, temperature and pressure. Tell you that whenever a solute is dissolved in a solvent, that process is called dissolution. Okay. Now, if I talk about the solubility, we'll be discussing two types of solubilities since we are discussing liquid solutions. So, solubility of solid in liquid and then solubility of gases in liquid. Okay. So, the very first thing is that how the nature of solute and solvent affects the solubility. So students, you might have heard of this line ki like dissolves like. Now sugar, salt, they readily dissolve in water. Okay, but naphthalene, anthracene, they don't dissolve in water but they dissolve in benzene. Now why is that so? Because if the nature of solute and solvent is same, the force of attractions would be same and it helps in solubility. That means like dissolves like. Means the polar substances will be dissolved in your polar solvents and non-polar substances will be dissolved in non-polar solvent. For example, sodium chloride, sugar, these are polar. Okay, so they will dissolve in a polar solvent which is water. Naphthalene, anthracene, these are organic compounds, you know. So they are going to dissolve in non-polar solvents only. For example, benzene or carbon tetrachloride or any other non-polar solvent. So that is the meaning of your like dissolves like. Okay. Now you know about these terms saturated, unsaturated solution. Okay. So what happens, students, is so when a solute is added in a solution, its concentration increases. This process is called dissolution. Otherwise, some solute particles, they collide with the solid solute particles and they get separated out of the solution, which is called crystallization. So there is a time when these two processes happen at equal rate. Means the amount of dissolution is equal to the amount or rate of crystallization. Okay. Means the rate of dissolution is equal to rate of crystallization. So amount of solute going into the solution and amount of solute coming out of the solution is equal. At that time, the system exists in a dynamic equilibrium. Okay. And when that equilibrium is disturbed, that's what the solubility increases or decreases. That's what we'll discuss. So what is a saturated solution? If the concentration of solute in the solution remains constant at a given set of temperature and pressure, means if this dynamic equilibrium is reached, now no more solute will be dissolved in the solution. So if no more solute is dissolved into the solution at that particular temperature, it is called saturated solution. And if we are adding more solute to it, it would precipitate out. It will not dissolve. Okay. And unsaturated solution is when the equilibrium has not yet reached. Means if you can add more amount of solute to a particular solution and it gets dissolved in it. Okay. So that is known as an unsaturated solution. Okay. So nature of solute and solvent we have discussed. Now let's see how temperature and pressure affects the solubility. So first is the effect of temperature. Remember students, we are discussing the solubility of solid in liquid. Now I told you that a dynamic equilibrium is there between the solute and solvent and the solution. Now this thing follows the Le Chatelier's principle. Now you must know, students, what is Le Chatelier's principle. Although it comes in class 11th equilibrium chapter, I will recall it here for you. Okay, just in brief, and then we will discuss it. So here there is an equilibrium between the solute and solvent and the solution, right? So Le Chatelier principle says whenever a system that is in equilibrium, okay, it is subjected to any change. It can be the change of concentration, temperature, pressure. So the equilibrium will shift in such a direction so as to undo the change. Okay, so as to undo the change. Means it would like to undo the effect of whatever that change is done, and means it would like to achieve the equilibrium again. Now let me tell you what is happening in the case of temperature. So you know that the dissolution process, like there are two types of processes based on the temperature change. Endothermic, the process where heat is absorbed, I hope you all know that, and exothermic, where heat is released. Okay, so the change of temperature will affect these two type of processes only. Now you know the dissolution also can be exothermic and endothermic. Means when you are dissolving any solute, either heat would be absorbed or heat would be released. Now what happens is, according to Le Chatelier's principle, whenever we are increasing the temperature, okay, so whenever you increase the temperature, the system would like to, or the equilibrium would like to shift to that side. Now tell me which side it will shift. It will like to shift to that side that absorbs heat, right? Because we are increasing the temperature, the system likes to undo that change, means it would like to absorb that temperature. Okay, so it means the endothermic process will be favored in this case. Okay, endothermic process will be favored because here heat is absorbed. Similarly, if we are decreasing the temperature, the system will shift in that direction that releases heat. Means it would like to have more heat because we are lowering down the temperature. Okay, so it means it will favor the exothermic process. So please keep it noted, please keep it star mark, very important point, that increase in temperature favors endothermic reactions, whereas decrease in temperature favors exothermic side. Okay, now whenever your dissolution is let's say endothermic, okay, so here you can see, means if the dissolution is endothermic and you are increasing the temperature. So just now I have told you कि increasing temperature favors endothermic reactions. So dissolution is endothermic and increasing temperature favors endothermic reaction, means the increasing temperature will favor dissolution. Means the solubility will increase on increasing the temperature if the process is endothermic. But if the process is exothermic, okay, so in that case, if you are increasing the temperature, it would favor the backward reaction. Okay, means the solubility would decrease. So keep that noted, that if the dissolution is endothermic and if you are increasing temperature, it will increase the solubility. If the process is exothermic, increasing temperature would decrease the solubility. And let me tell you that, students, there is no effect of pressure on solubility of solids in liquid, because the solids in liquids are mostly incompressible. So there would be no significant effect of pressure change. Okay. So I hope this much is clear. Effect of temperature, this is very, very important. So students, this was about the solubility of solids in liquids. Now let's talk about the solubility of gases in liquid. Okay, so you know that it is again dependent on the nature of solute and solvent. So like you know, oxygen dissolves only to a small extent, but HCl is highly soluble in water because of the polar nature of HCl as well as your water. Okay, so this affects the solubility. Now if I talk about pressure, so the solubility of gases in liquid is highly affected by the pressure and the temperature. Can you see here this diagram? So here these are the gaseous molecules which are present in the liquid. In this case, the number of gaseous particles entering the liquid and leaving the liquid is same. Okay, the rate is equal. So it means there's an equilibrium. Now what we are going to do here is we are increasing the pressure. So this is the piston, we will be increasing the pressure. So in that case, the number of gaseous particles per unit volume increases, as well as the number of gaseous particles striking the surface of liquid also increases. So in that case, the solubility will increase. Okay, the solubility of gases in liquids increases with increase in pressure, and this was first studied by Henry, so we call it as Henry's law. Now Henry law stated that at constant temperature the solubility of any gas in a liquid is directly proportional to the partial pressure of that gas, like whatever is the partial pressure of the gas present above the surface of liquid or your solution. Okay, so generally if we say ki what we have studied about mole fraction is actually the like ratio of number of moles of gas and the solute and the solution. So if we see here that the mole fraction of the gas will be the measure of its solubility, means more mole fraction means more solubility. So in that way we can write the Henry law as कि मोल फ्रैक्शन ऑफ गैस इन अ लिक्विड इज प्रोपोर्शनल टू पार्शियल प्रेशर ऑफ द गैस की जो मोल फ्रैक्शन होगी गैस की मींस सॉल्युबिलिटी होगी इट विल बी डायरेक्टली प्रोपोर्शनल टू पार्शियल प्रेशर ऑफ द गैस की मतलब जितना ज्यादा प्रेशर उतनी ही ज्यादा सॉल्युबिलिटी अगर इफ देयर इज लेस प्रेशर देयर वुड बी लेस सॉल्युबिलिटी ओके So in that way we can say Henry law is that partial pressure of the gas in vapor phase is proportional to mole fraction of the gas. Okay, so the partial pressure hai, it is denoted by P, it is proportional to mole fraction which is X. Now if we remove this proportionality sign it will be KH into X. Now what is this KH? KH is your Henry constant. Okay, it's Henry's constant. And it is actually the function of nature of the gas, means the value of KH will depend on the nature of the gas. So if I tell you that different gases have different KH values, so means KH depends on nature of the gas. If the value of KH is high at any particular temperature, okay, so from here you can say KH is P upon X. So if the value of KH is high at any given pressure, all right, the solubility would be less because they are inversely proportional, and so that's what we can say higher value of KH means lower solubility. And tell me let me tell you students, the question from this topic was asked in your Neet previous year examination. You go through the PYQ book now, you will see that there will be 2 or 3 questions that have been asked repeatedly based on this Henry's laws constant. Okay, from there you just have to compare the values of solubility. So for that you must know कि higher the value of KH, lower will be the solubility of any gas. Okay, now if I talk about temperature change, so see students, dissolution of gas. So whenever there is a dissolution of gas in liquid, it's an exothermic process. Okay, means heat is released in a reaction. And just now I have told you कि exothermic processes are favored by low temperature. So it means if we are increasing the temperature, what will happen? The solubility of the gas will decrease. So keep that noted कि the solubility of the gases decreases with increase in temperature. Okay, so that is the very important thing. Please note that. Now there are some applications of Henry's law as well. So you know, to increase the solubility of carbon dioxide in your cold drinks, the cold drinks that you drink na, the bottles are sealed under high pressure because just now we have discussed कि more the pressure, more will be the solubility. So then there is this condition known as bends, right? When these divers go deep into the sea, what will happen? There is a lot high pressure like that pressure increases with increase in depth of the liquid, right? So when the scuba diver goes deep inside the water, okay, what will happen? A lot of gases will dissolve because of high solubility of the gases. Okay, now when they come at the surface, those gases will try to come out. That will create a very painful condition which is known as bends. Okay, so that can rupture the blood vessels as well, because a lot of gases get dissolved in our blood at the high pressure. So that's why the air used for scuba diving, it is diluted with helium gas. They take the cylinders, no? So that is diluted with helium to prevent this condition. Okay. So students, that was related to the solubility. I hope it's clear. Now we will be talking about the vapor pressure of liquid-liquid solutions. So students, now if I talk about vapor pressure thing, okay, for liquid-liquid solution. So liquid solution means where the solvent is liquid, okay. And students, that whenever we are having a solution, let's say of two volatile liquids, means both of the liquids are volatile, both of them. So in that case, the liquids will evaporate, right? Let's say if you are having a closed container, so both the liquids will evaporate and there will be a equilibrium between the liquid state and the vapor state, right? So a liquid equilibrium will be established between the liquid state and the vapor state. Now this thing, now let's say if the vapor pressure, total vapor pressure is P total and the vapor pressure of the two components is P1 and P2, because there are two liquids, no? And we will be relating them with their mole fraction. So mole fraction of component 1 is x1 and mole fraction of component 2 is x2. Now students, this is related by the help of Raoult's law. Now Raoult's law states that if we are having a solution of volatile liquid, so the partial vapor pressure of each component, okay, partial vapor pressure of each component, let's say P1, is directly proportional to the mole fraction. Means P1 is directly proportional. P1 is directly proportional to x1, okay. So if I remove the proportionality sign, it will come P1 naught x1. Now this P1 naught is the vapor pressure of the pure solvent, okay, means whenever it is not mixed, but then what is the vapor pressure? That is P1 naught. Similarly, I can write P2 is equal to P2 naught and x2. Now from here you can see that the vapor pressure will be directly proportional to the mole fraction, and this is the straight line graph that you are going to get. So you have to remember these two formulas in this case, okay. So now you see here we have taken the Raoult's law. Now if I talk about the Dalton's law of partial pressure, so the total pressure for the component will be, total pressure would be equal to the partial pressure of each of the components, okay. So from here I can say P total would be P1 naught x1 plus P2 naught x2. Now students, if there are those two components, the sum of mole fraction would be 1. So I can say x1 is 1 minus x2. So from here P total would be P1 naught, and here I can say 1 minus x2 plus P2 naught and x2, okay. So from here I can say it is equal to P1 naught plus P2 naught minus P1 naught into x2. So what conclusion I can draw from here is that the total vapor pressure can be related to the mole fraction of any one of the component, okay, means I can write in the form of x1 also, I can write in the form of x2. So the vapor pressure can be related to the x2. So this is related to your liquid in liquid solutions, okay. So here we have taken the Raoult's law in combination with the Dalton's law of partial pressure. See, this is how it is. And see, this law is applicable only for very dilute solutions and for non-volatile solutes only, okay. So that is the thing. Now let's say if there is a solid and liquid solution, okay students, so whenever there is a solid in liquid solution, then what happens to the vapor pressure, that we have to see. So students, for solid and liquid, you all know that like whenever a liquid tends to vaporize, you have studied it, like what is vapor pressure. So whenever a liquid tends to vaporize, so under equilibrium, the pressure exerted by the vapor state on the liquid state or the liquid phase is called vapor pressure. So whenever, let's say, there is pure solvent, so here the vapor pressure is because of the solvent molecules only. Okay, you can see here on the surface, these are the solvent molecules which tends to vaporize, and the vapor pressure is because of solvent molecules only. But whenever, let's say, I have dissolved a solute in it, so can you see the vapor pressure in this case actually decreases. So whenever we are having a solute, non-volatile solute is added to it, so the vapor pressure decreases. Now why is it so? Because you see now on the surface, the fraction of molecules of solvent decreases because the solute molecules or solute particles also occupy this surface. So if the fraction of molecules of your solvent decreases, it means the molecules going into the vapor state also decreases, and hence the vapor pressure decreases. So that is why for a solid and liquid solution, you must know that whenever we are adding a non-volatile solute to a solvent, the vapor pressure will decrease in that case. Okay. And you must know that this decrease in vapor pressure, it will depend on the quantity of the solute rather than on the nature of solute. Let's say if I am adding 1 mole of urea, or I am adding 1 mole of sugar to your water, okay, or to your solution, so in that case the lowering in vapor pressure would be same because the amount is same. It is not depending on the nature of the solute, it depends on the quantity or the amount of solute. Okay students, so this was related to your vapor pressure. Firstly, we discussed it for liquid in liquid, where we discussed the Rolle's law. Then for solid in liquid, where the vapor pressure decreases. Okay. So I think this first part of the chapter is clear to everyone. Now again, I would like to say you, if there is any doubt, okay, please comment below in the comment section. Please let me know so that I can clear your doubts in the next lecture. Alright, please go through this complete lecture. After that, what you have to do is, you have to go through your NCERT. Okay. So you know that for NEET examination, following NCERT is very important. So go through the NCERT. Whatever I have covered today, most of it I have taken it from NCERT. So you have to go through it, read it thoroughly, and solve the questions that are there. The in-text questions as well as the solved examples. Okay. So again, if you solve more and more number of questions, your concepts would be clear. Because this chapter also is having a lot of numerical problems. Alright, so please go through it students. Any doubt you can ask us through our Telegram channel. I am again telling you, please go through the Telegram channel. Please join it. Link is in the description. Okay, there you can interact with us. You can ask your doubts. They'll be asking you interesting quizzes and daily targets will be given. Please go through that. Okay, and prepare well. So I'll be meeting you in the next lecture. So until then, take care students. Thank you. Bye-bye.